Hey, Dr. B here, and let's name some binary molecules. Those are molecules that only have two different types of atoms. Let's do it by example. You may know that molecule as water, but the technical name for it would be dihydrogen monoxide. Notice we use mono, di, tri for the subscripts, and even mono if it's just a 1. And we just use the oxygen becomes oxide. That's water. You may know this substance as ammonia, but the technical name using what we just learned would be, you might say mononitrogen trihydride. However, think about CO2. It's not monocarbon dioxide, is it? So we drop the initial mono, we just do. And we name that substance nitrogen trihydride. We now have a systematic method for these substances. Common name, ammonia. Apply that to this substance. The common name is hydrazine, but now you should be able to name that dinitrogen tetrahydride. So that's how we do it. But if it's ionic, there's some different rules. And once again, you already know this stuff from example. Let's name these substances. NaCl, you know that should know that it's sodium chloride. Notice we didn't say sodium monochloride. We learned something. We don't use mono, di, tri for ionic substances. End of story. Maybe we should have, but we don't. This one is to the right of the staircase, therefore it's covalent, so name it carbon monoxide. Perhaps you already knew that. So just learn to apply those. No mono, di, tris if it's a salt. This one is a salt, so we better just say aluminum chloride, not aluminum trichloride. How did I know it's a salt? The staircase. Aluminum's to the left of the staircase on the periodic table. It's a metal. Chlorine is to the right. The only time you'll screw that up is with the polyatomics, right? Like the ammonium cation. It's not a metal, but it does happen to be a salt, but with only rare exceptions here. So this one, everything's to the right of the staircase. What do you like? Sulfur dioxide. Okay, a new rule is going to kick in here. FeO2, you might just say iron oxide. The problem is that you're in the polyvalent region. These transition metals can have multiple states, and in fact, you might be able to buy a bottle of FeO. How are we going to differentiate it? We'll simply include the charge in the molecule using Roman numerals. Therefore, we're going to say that this is iron what oxide? Well, each oxygen has a -2 charge, so we've totaled up -4 on the anion side. This better be +4 on the cation side. This is iron 4 oxide. How about this one? You might be tempted to say silicon 4 oxide, but you'd be wrong. Reason, silicon is to the right of the staircase, just barely, but just the same. Therefore, we simply say silicon dioxide. If you're a flowchart person, which I'm not, you could use these rules. Ask yourself, is the first element a metal? If it is, we are not going to use the mono, di, tri. And then you say, is it in the polyvalent region, like the transition metals and a little to the right? It is, and if it is, we better use the Roman numerals. More often, students get this, but they apply it a little too far. So, for example, if you said name NaCl, be careful. Don't say sodium 1 chloride because it's not polyvalent. It's just in group 1. It's always +1, so we would just say sodium chloride. This is how to name binary molecules.